Yeah, good evening, everyone. So, Chennai camps, let's start off. This was the last thing that we did. Sure, camps on everyone. The next one is a sector. This is angle theta, and the radius is r. Find the center of mass. So, for this, the elements are arcs. So, whenever you see a sector, generally this is how you choose elements. This is how you choose elements. So, basically, you divide this entire sector is like a pizza ka slice. You divide this into thin slices, then it becomes a small arc. And arc का center mass ना last class we designed. We derived 2r sine theta by 2 by theta. So I'll just explain you the concept what you're trying to do now here. We are going to divide this into multiple arcs. Each arc will have a center of mass. And we are going to find the center of mass of these center of masses, and that will be the center of mass of the sector. Isn't that the whole idea? Right? So give it a try. I'll give it 2 minutes. Give it a try, then I'll show you. If you make theta is equal to pi, that becomes a half disk. So that's the general thing. Find the center of mass of an arc. I hope everyone has given the test. I extended till today night in case someone has not given, do give it. Is the site opening now, right?
Yes, sir.
There was some server maintenance, it seems. Adrit, your video is very colorful. We can't see. And you guys have PTM tomorrow. Most of you, I think it is tomorrow for you guys. So, how do you find the center of mass of this sectors? Two r sine theta by 3 theta. Nah. If you put theta is equal to pi, center mass of half disk. So at a distance r, we will take a thin slice dr. Like I keep saying, the major headache of these things is finding the elements and their masses and all that stuff. So for this arc here, so this length will be r theta, the arc length. So that area will be dA, will be the length r theta into dr. So mass dm will be sigma into dA. In this case, we take sigma, mass per unit area, because it's a sheet. So sigma r theta dr. And for this guy, the center of mass will be here, which is 2 small r sine theta by 2 by theta. This is the center of mass of arc. Now that formula becomes, we are doing anyway y coordinate here, y coordinate of center of mass of sector. Listen carefully here. This will be integral y coordinate of the arc, mass of the arc. So that formula integral y dm by integral dm, what it says is this is the y coordinate of center of mass of this mass. Now, what is this mass? This is an arc by integral dm of the arc. Is this making sense? So you're finding the center mass of each arc, and then you're finding center mass of all these center masses, and that should be the center mass of the whole sector. Udayan, you need to keep your cam on. So then y of this thing will be 2r sine theta by 2 by theta. Theta is constant anyway. Sigma r theta dr. This will go from 0 to capital R. Sigma r theta dr. Sigma cancels off. Theta cancels off. These are constants. Then you can put sine theta by 2 by theta outside. 2 also. R square dr from 0 to r. R dr 0 to r. That would be r cubed by 3. This would be r square by 2. That would be 4r by 3 theta sine theta by 2. That's your centrum as well as sector. If theta is equal to pi, we get a half disk, semicircular disk. This is a standard resolution you need to remember. If you substitute theta is equal to pi there, you end up with 4r by 3 pi. Center of mass will be at so for this thing, the center of mass y coordinate will be 4r by 3 theta on the bisector. Do check out this integration. Clear? Check it out how I did this. Clear, everyone? Next one. Next one, what if you take a hollow hemisphere? Radius r. Here the elements will be like this, rings. Think of like this. Imagine you have a watermelon. Take a watermelon, cut it horizontally like this. Then what you get? You get a disc, right? From the disc, remove the red color part in the middle. If you remove the red color part, अभी क्या बच जाएगा? The green color band, right? Able to visualize how is the element? If you take a watermelon, slice it horizontally twice, so you get a disc. And if you remove the red color part, what's left out is a that green color ring. So that is how we are going to choose elements here. So this is how the element looks. I'll just give a little idea here. You can try the values here. Just look at this thing, how I take the elements. Like I'm saying, these things you should know. Like, I should take elements like this. वो तो रट्टा मारना ही पड़ेगा. Option नहीं है. So from the center, at an angle theta, take a ring with small width d theta, meaning this will be rd theta. So we got a ring whose thickness is rd theta. This is theta. So this is theta. So this height will be r sine theta. And this radius will be r cos theta. So if you take a scissor and cut it here and open this, you will get a rectangle like this. This rectangle ka length will be 2 pi r cos theta. And this width will be rd theta. And for this ring, the center of mass will be 0, r sine theta. This is the center of mass of the ring. So for this small piece, the area dA will be length into breadth. So 2 pi r cos theta into rd theta. Mass dm will be sigma dA. So for this, the formula y center of mass of hollow hemisphere will be integral y center of mass of ring. dm is the ring ka mass. So that is the meaning of integral y dm. By integral dm ring. The y of the ring is r sine theta. dm of the ring is sigma 2 pi r square cos theta d theta. Limits will go from where to where? If theta is 0, you will take this ring at the bottom. As theta is increasing, this will be the ring, this will be the ring, this will be the ring. At the highest point, theta will be 90. Got it? So when you go from 0 to 90, all the rings are covered. So the limits will go from 0 to pi by 2. This will be denominator sigma 2 pi r square cos theta d theta 0 to 90. Chalo, you get the integration. So whenever you see a hollow hemisphere, or I'll show you, you'll get the same idea even for a cone also, hollow cone. We take rings. So like the main idea is for different shapes, you should know what kind of elements you should choose. Have a look at this, how I took the elements. You get a very decent answer actually. You should get R by 2, everyone. Try. See, this thing 2 pi r square, sigma will cancel. Remember, you can only cancel constants, huh? Don't cancel anything. Be careful. When r comes out, you stuck with sine theta, cos theta, d theta, 0 to 90 by integral cos theta. Integral sine theta, cos theta can be written as sine 2 theta by 2. This would be 1 by 4 cos 2 theta. Limits will go from 0 to pi by 2. This would be minus 1 by 4 cos pi minus cos 0. That would be half. So this would be r into half into denominator will come 1. So this is r by 2. That's your answer. So this center of mass is r by 2. So a good answer. Yeah, r by 2 from the center. Check it out. Clear? Great. Next one. Let's say we got a square plate 0, 0, a, 0. Where sigma is equal to sigma naught x into y. Meaning the density of this plate is changing with both x coordinate and y coordinate. Sigma naught is some constant. Sigma is surface density. Meaning density at a point depends on the product of x and y coordinate. Higher the x and y coordinate, the more massive it is. Meaning on the x-axis, y is 0, so there is no mass here, there is no mass here. But as you're going, it is becoming heavier, 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 and heavier. I hope you're getting how is this. So it's a plate whose mass is changing with x and y. Find the center of mass. How do we do this? Try. Right, Anika. You got it. Solved it. Guessed it. Solved it. See. One way to guess this, right? If it was me in the exam, I would guess it. And this is how I will guess it. This plate which is there, if you think about it, when you're traveling in the x direction, right? So if you see only the x coordinate is changing and y is not changing, doesn't look like a rod which is changing like lambda not x, isn't it? Doesn't look like a rod which is changing with lambda not x, right? Same way in the vertical direction, it looks like a rod which is looking lambda not x. So let's see whether that result works or not. So we should get something like, for a rod with lambda not x, what is the answer? 2a by 3 and 2a by 3. Now we have to see whether that works or not. Let's see. So first, how to choose elements for something like this? For a rectangular plate, the elements are sigma naught x square. Let's see. The elements are small squares or small rectangles. This is what we do. At some distance here, take a small slice like this, whose width is dx, whose height is dy, and the coordinates are x comma y. This is called double integration. This is something new. So listen carefully. So mass of that small piece will be sigma, area will be dx into dy. So this would be sigma naught x dx y dy. So when you integrate this thing, the position vector of center of mass, this would be integral r bar dm by integral dm. This r bar would be xi plus yj. We put a double integral because there's a dx and dy, both of them. We don't have double integration in the portion technically, but it's not really difficult to learn. Max method, they will teach you little basics of it. So sigma dx y dy. You have to put two integral signs because there's a dx and dy. So double integral sigma naught x dx y dy. Idea is pretty simple. So when you do for this, I can do one thing. I can do only for x and show you for y is also same. But okay. So this would be sigma naught is constant anyway, that goes off. Then you get double integral x square dx y dy I cap plus double integral x dx y square dy. This would be sigma naught. So basically double integral, what you do, right? You simply give one integral to dx and one integral to dy. Limits will go from x0 to a and 0 to a. Sigma naught will cancel, and this thing turns out to be integral x square dx, integral y dy, 0 to a, 0 to a. This is I cap plus integral x dx, 0 to a, integral y square dy, 0 to a. Denominator you have integral x dx, 0 to a, into y dy, 0 to a. So this would be x square integral will be a cube by 3 a square by 2 I cap plus a square by 2 a cube by 3 j cap and a square by 2 and a square by 2. 2 cancels, a square by 2, a square by 2 cancels. You will end up with 2a by 3 I cap plus 2a by 3 j cap. That's your answer. Check it out. So later on, right, in volumes also you can get a triple integration. Triple integration will be like something rho dx dy dz. It's called a triple integration. Basically, you simply have to give dx ke liye one integral, all y ka terms one integral, and all z ka terms one integral. You just split it. This is how you integrate double integration. This much basic idea you should have. Don't worry too much about double integration. Technically, it's not in the portion, but yeah. They'll expect you to solve one integration after another, but double integration will just save you time. You can finish off in one go. Check out how we choose the element.
Sir, in the final answer that I cap and j cap of our theorem, what does that
Mm-hmm.
actually signify? Like,
Meaning for this plate, the center of mass is at 2a by 3, 2a by 3.
acha, okay.
Isn't that the center of mass ka formula? This is the center of mass, no? Position vector of center of mass of this weird plate is 2a by 3, 2a by 3. Check out this integration how I did. we take one diagonal rod as center of mass lies on the line of symmetry. Idea is not bad, but the problem will be that much I know. It will lie on the line of symmetry. What do you mean we'll take a diagonal rod?
Sir, but
The
it-
mass won't change linearly, na? Mass won't change linearly. Mass is changing as a function of xy. It is something else. It's a weird function. It's a hyperbolic function. You can't solve by taking diagonal rod. And what will take the length of the rod as? A root 2. It doesn't make sense. You can't take. Now, Utsa, you're saying something?
Sir, what if we took like a rectangular thing with length is A and the height is dy?
Then you have to integrate in that rod also again.
Hmm.
So first you have to integrate for this rod and then integrate all these rods.
Would that
So
work?
instead of that, I just did double integration at the same time.
Okay.
End of that, you're integrating 2 times, right?
Hmm.
I did the same thing, but at once.
Okay.
Next one. Solid hemisphere. Radius r. Now here we have two choices actually. We can choose the elements as thin disks. Or indicate elements as thin hollow shells. Like this. Ever seen an onion ka shells? If you ever seen an onion, you'll find layer upon layer. It's like layers of onion. Shell upon shell, shell upon shell. So what we will do, right? We will use thin hollow shell. Thin disks, I'll show you with another problem. So whenever you have hollow hemisphere, solid hemisphere, you have choices. You can take either thin disks or you can take thin hollow shells. Both will work. Let's do right now with hollow shells. Thin disks, I'll show you for a different shape. Try. You got a minute or two. Again, the idea is the same. Take a thin hollow shell, find its center of mass, find its mass, and then find the center of mass of all these hollow shells ka center of masses, and that should be the center of mass of this thing. 3r by 4, that is wrong. That is the right element, Adrit. How do you take the volume of this thin shell? Surface area 2 pi r square into thickness dr. Try. I'll give you a minute more, then I'll show you. Let's see. So this thing, the small volume dV will be surface area into thickness. The surface area will be 2 pi small r square. So this small r is the radius and this thickness is dr. So this will be the volume. The mass will be rho into 2 pi r square, rho into dV, 2 pi rho r square dr. This is the mass of this thing. And the center of mass of this guy is 0, r by 2. This is the center of mass. The center of mass of this hollow shell is 0, r by 2. Remember, smaller is a variable here. So y center of mass solid hemisphere is y center of mass of that shell, mass of that shell by total mass of that shell. So that is how we are actually using that formula integral y dr. Nay, Swastika, check your calculations. So this y will be r by 2, dm will be 2 pi rho 2 pi r square dr. This will go from 0 to capital R by integral 2 pi rho r square dr 0 to r. 2 pi rho will cancel out. You end up with half r cube dr 0 to r by integral r square dr 0 to r. This turns out to be 3r by 8. Yep, that's the answer. Check it out. You will make a table and end all the main important shapes, because in mains, right, they do have sometimes direct results also. I think 2019 or 18, they asked the center mass of a solid cone. Straightforward question. Have a look at this. Let's see how to use the disk. I'll show you. Any doubts on the integration? How you choose elements? Like I'm saying, right, the most important thing is this part. If you understood this part, it is sufficient. The remaining is fine. Because this, what the way we are choosing elements, it won't stop here. We will do it in rotation, fluid, electrostatics, gravitation, magnetism. At least 5 more chapters you'll encounter this kind of stuff. And people who are looking for advanced, this much integration should be quite comfortable choosing an element in integration. Luckily, In physics, sub mila ke, I think you have something like 4 to 5 elements. That's it. So it is not really like too many varieties also. So main thing you should see, the moment you see a shape, you should know like, yeah, I should take an element like this. That much idea you should have. All clear with this? Now you tell me how will you take element for this guy? This is a paraboloid, a 3-dimensional parabola. Solid, huh? You know what is the shape? It's like if you rotate the water in a bucket. Ever seen the shape which you get? That bowl shape is actually a paraboloid. Or ever seen in Enfield ka headlight? If you see this old Enfield ka headlight, observe that the headlight looks like this only. It's like the curvy shape thing. So 0, 0, and let this guy be 1, 1. The equation is y is equal to x square. It's a parabolic equation. The shape would kind of look like I hope you're able to visualize. It's like a bowl, solid one. Find the center of mass.
So solid, matlab the top part is also, it's still the top part, right? And one.
What do you think? Let's see your English. We will test the school of your English of your school. If I said it's a solid paraboloid, what do you mean by that? You mean it is solid here and there's a holes inside. Think of like this thing, na? Ever seen this thing? Sweet potato or any potato? You have a potato like this, just break it, na? वो तो है ना solid. पूरा solid है रे. Here people have problem with on the body, with the body. People get confused with this small words. Arjun, you lost easy 4 marks because of that.
And so that was okay. Fine.
नहीं होता है एग्जाम का टेंशन में ना anything becomes anything. Get this thing. How will you choose an element for this? Now, this is not any standard shape. It first of all, it's a 3D shape. Able to visualize how to take an element? Take a thin discs. Did you ever see if you take a potato and if you cut it into slices, what kind of shape do you get? If you take a potato here and if you cut it into slices, you get thin wafers, na? Able to visualize?
Yes.
That is how, don't they make chips, potato chips or something of that sort? You're cutting into thin slices. So it's like a discs. So this entire thing is made of multiple discs. So it's like a disc, 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 disc. So you are combining all these discs to get the shape. You could have done the same thing with a solid sphere also, but there we used hollow spheres. We will use here discs. The main idea is that to figure out how to choose an element. So here the elements are thin discs. You should always take a shape which you can find actually its mass, volume, whatever it is. You can't take any weird elements. Thin discs. Now try. I'll give you 2 minutes. If these are the options, can you guess which are wrong?
पहला वाला तो wrong है.
Why?
Symmetric.
Symmetric? Complete na?
Sir, symmetry से देखेंगे तो x
There should be along y axis, so you're wrong. Yeah, ठीक है. Then See, I can't tell which is right, but I can tell which are wrong. That is the whole concept of elimination. In eliminations, you can never find out the answer. You just have to eliminate 3 options. Why third and fourth are wrong?
Because the mass as we go up will increase, so the center of mass will be above the midpoint.
इतना तो बोल सकते हो ना. If you see, the mass on the top part is more than bottom. Center mass can't be at the middle. It should be more towards upper side. That much we can guess. Right? So 1, 3, 4 are wrong. This thing, I don't know. Actually, this is also wrong, but ठीक है. That's all. Let's get the answer. Whenever you solve a question, the first thing you should do is, can I guess? And if you can guess, mostly you will guess in 10-15 seconds. If you can't guess in 10-15 seconds, it means you can't guess. Start solving. That is the essence of solving questions. Again, be very clear about it. Your job in the exam to crack questions. It's not about solving. Now that cracking can be by guessing or maybe by some magic. If you can get an answer, get it. In the exam, what matters is only marks. Out of the exam, what matters is only subject. If you can't make that distinction, you will get stuck. Because people keep saying, I studied so much, I learned so much, but I didn't get marks. Bullshit. You learned everything, but you don't know how to write an exam. Studying is one part. Writing an exam is a second part. Handling yourself is a third part. When these 3 things come together, you will do really well in the exam. And the day when you do really well in the exam, you need not even see the answer key. You'll write the exam, you'll come out and you'll say, I have done well. And you're exhausted. And if someone, it happened with me multiple times. When you did the exam very well, right? And you come out, you don't remember anything else. If someone asks you, what is your name also, you will, Arun. You think for a moment. Means you have given your best. And that day, you crack the paper. That, we call it a Zen state. You need to reach that thing. Happens a lot. We have one answer, 2 by 3. Any other answers? Three by 5. I don't think so. See. So let this point be x comma y. So this thing, let the thickness be dy. Let this radius be x. So what you actually got is a thin disk like this. Whose thickness is dy and whose axis is this thing. This thing has a center of mass 0, y. That's your center of mass. So dm will be rho into pi x square dy. So y center of mass of this paraboloid is integral y center mass of the disk dm of the disk by total mass of the disk. If you see, I'm just changing the shapes, but the general way of solving is always the same. What you need to mug up is the general way of solving. You mug up the technique of solving. Don't mug up the questions or answers. Ratta to marna hi padega, but what you are remembering is different. If you remember the techniques, then you'll understand way to apply and way to adjust. If you just remember for this question, then you're lost. This will be y rho pi x square dy. Rho pi x square dy. And don't forget, it is given y is equal to x square. So just replace x square with y. So this will be y dy by y dy. I just replaced x square with y. This becomes y and this becomes y. Rho pi will cancel. This will go from 0 to 1 and this will go from 0 to 1 and this will come 2 by 3. See, once you got the element, integration is like what, 2-3 steps. Choosing an element, getting it out. Main problem kya hai na? You see the question and people start panicking. There's like, what the hell is the shape and all. So the most important thing when you see a question, shut your mouth and read it properly. Don't panic, right? You have to be calm. That is the main thing. You start panicking, everything will go for a toss. Remember, I was telling you how to save a person who is drowning in a swimming pool? Did I tell you? What do you do? First, you go and slap them. First, you calm them down. The point is that because this person, right, who is drowning, he's panicking and scared. If you go near him, he will jump on you and catch you. So he will drown, and with him, he will make you also drown. Both of you will die. No matter how much you tell him, na, it is okay. I'm a very good swimmer. I will save you. Arre, kuch sunega nahi wo. He is in such a panic mode. He will not understand. He just wants to live. He will catch you. He won't let you also swim. Both of you will drown. So by chance you get close to him, slap right, left. He'll be under shock. In that time, catch the air and pull him and drag it out. That's how you save someone. So mostly if you see a professional swimmer, right, they won't even get close to the victim. They'll try to be little far. They'll catch their hair and they drag them out. That is the thing. So it is most important you go to the exam, you see something weird, calm down and try to understand if this is tough for me. You know how I used to handle? If I used to see something really weird question, I used to read, and if it is really tough, I used to say, if I found it tough, matlab in the country, almost 99% of the people will feel it tough. It's a tough question. So that is okay. Getting it, and then so if I solve it, I used to feel like, okay, good, I did it. If I didn't solve it, I used to say most people couldn't have solved it. And that's kind of an overconfidence. That used to work in physics. Maths mein dusra tha. Maths mein, if I don't get it, I know I didn't get it. So I had two kinds of confidence. So I was always a big, what do you call it? क्या बोलते इसको? Contradiction. When it comes to physics, I used to be like, give me anything, I'll show what I am. Maths also, no, you give me anything, I know what I am. So yesterday only there is one idiot. I was talking to one of your senior. He messages me, sir, physics I got 95 out of 100. Chemistry I got chemistry. Maths I got 95 out of 100. Can you guess how much I got in chemistry? Oh, मेरे से game खेल रहा था. He scored 37. Then he's waiting for me to scold. अभी क्या scold कर रहे? You know, from last 1 week उसका homework वही था. He's just sitting and reading chemistry like mad. So you will find weird people. Now that is one. So if you take few more shapes, now for these things we will not do the integration. They're a little rare, but when it comes, I'll show you. So one is a hollow cone, but the results are quite important. Hollow cone, actually we can prove it without any integration. So if you have a hollow cone of radius r and height h, the center of mass will be 0, h by 3. How can we get this? See, for this hollow cone, what I will do, right? If I take a thin slice like this, this is like a thin triangle, isn't it? For a hollow cone, it's a hollow cone, right? So on the top, if you draw a thin surface here, this is like a thin triangle. For a triangle, what is the center of mass?
Centroid.
Centroid. So center of mass is at the centroid. That means it will be somewhere here. So if this total length was L, this guy would be at L by 3. That means for all these thin triangles, these are the center of masses. So that means for this cone can be divided into a combination of multiple triangles where all the center of masses will lie on a circle like this. And if you find the center mass of these triangles, that should be at a height of h by 3. Make sense? There, you can prove that without integration. So for a hollow cone, the result is h by 3. That's a result you need to remember. Next thing. This is L by 3. This is H by 3. The next shape is a solid cone. But फिर भी ना, hollow cone, if you want to do, you can choose elements like this. You want to integrate, the elements will be thin rings. For a solid cone, the elements will be thin discs. Just like the paraboloid thing, you can take thin discs and solve this. If you want to integrate, the center of mass will be 0, h by 4. The results are important. We'll not do derivation for this. Now, if I just mark up all the results in one page, the first thing is a rod.
Could you go to the previous slide for a second? Okay.
I'll add this down. Uniform rod. Then if you take an arc, semicircle is important. Exam like bits, CET, all this, they'll have direct results. Arc is little different though. Sector, half disc, so this will be at the center. L by 2, 0 is the center of mass. This is L, 0, and this is 0, 0. This would be at 0, 2r sine theta by 2 by theta. This would be 2r by pi. This would be 4r by 3 theta sine theta by 2. This would be 4r by 3 pi. And then you have hollow hemisphere. Then we have solid hemisphere. Then we have triangular plate. Rectangular plate. Rectangular plate will be in the center. Again, uniform we are talking about. Hollow cone. Solid cone. Did I miss something out? Yeah. This would be r by 2, 3r by 8. Center of mass will be at centroid. This will be at the center. H by 3. Standard result. This much they should remember. Clear with the shapes? Can I go ahead?
For just 2 minutes.
Just put down roughly, anyway, we'll get the notes. Let's see a question.
Where would be the center of mass for a cylinder, like a solid cylinder?
Guess what will be the answer?
So the center,
तो हो गया ना इसीलिए नहीं किया मतलब you want you can draw. So symmetry तो दिख रहा है ना. I thought of drawing but then every damn shape you will keep drawing then so that like ये तो line of symmetry है ना and ये line of symmetry तो center है. So you can take it. Better than that, this will be a better shape. Cylinders are boring. What if you have an inverted ice cream cone? So there, we have an inverted ice cream cone, solid cone, solid hemisphere. Made of same material. This is your origin. This height is h. This radius is r. Find the center of mass. This is a pretty good question, right? Not exactly the center of mass, but after that, what comes? I'll show you. That would be quite interesting. You can frame even a multiple choice question or a matrix matching based on this. Get this thing. We have a solid cone connected to a hollow solid hemisphere as shown. Find the center of mass. Two h minus 3r by 16. H square minus 3r square. Neil, looks like you remember all the answers. Let's see next one. Solved it. चलो अच्छा है. Hmm.
Is it
Aaron,
good
how-
or bad answer?
Utsa?
Good or bad answer?
There's nothing good and bad. They just can be weird. There you go. So first thing, this guy ka center of mass will be where? 0, h by 4. Let this mass be m1. What is the mass? Density into volume of a solid cone. You should know the volume ka formula, 1 by 3 pi r square h. This guy ka center of mass will be 0, minus 3r by 8. So r you messed up the sign. Mass m2 will be density into volume is 2 by 3 pi r cube. X coordinate is anyway 0. So y center of mass will be m1 h by 4 plus m2 minus 3r by 8 by total mass. So this would be rho 1 by 3 pi r square h. This is actually an easy equation. It just looks weird. Numbers are looks bad, but it is easy to solve. Don't get confused between a question, where you have to think a lot and where you have to solve a lot. Lengthy questions are fine because JEE papers are lengthy. Tough questions are something else. You see them, it doesn't strike on you what the hell is happening. So rho cancels 1 by 3 pi r square rho 1 by 3 pi r square rho 1 by 3 pi r square rho 1 by 3 pi r square. This going to be h square minus 3r square by 4h plus 2r. That's your answer. Yeah. And if h is equal to root 3r, center of mass will be at the origin. We could ask you that also, find h by r if the center of mass is at the origin. Now, how can they make this question even better? Have a look at these values there. This was the statement you wrote, remember? If you have a system, divide this into any number of parts, find the center mass of each part, and find the center mass of those center masses. That weird statement which we wrote was all about these kind of questions. Any doubts on this? So in this, something more interesting happens. Now see, if h is greater than root 3r, the center of mass will be above. So if you make a toy like this, right, where the lower part is lighter and the heavy part is, upper part is heavier, and if you tilt this toy, if disturbed or tilted, the weight vector will act from here, mg. The normal reaction will act from here. This is actually based on rotation, but if you observe, it rotates in this direction. Means you push it to the right, the body also rotates towards the right. What kind of motion is this? What kind of equilibrium is this? Unstable equilibrium. Meaning this toy will completely invert and eventually will fall down like this. It won't remain vertical. This forms a couple here. The mg is rotating this way and this n is pushing that way. It forms a torque couple. So this is an unstable equilibrium. If h ka value is less than root 3r, generally when they make kids ka toys, this is what they do. What they do, right? They make the bottom part with some plastic and the upper part with a balloon. No matter how much you kick it, it always keeps coming back. Ever seen that such a kind of toy? Kids ka toys especially. Or if you remember this scene from Kung Fu Panda 1 movie, this thing, right, goes to the dojo for practice. Everyone is doing all kind of stunts. The master asks, this Po, like, what do you want to do? He says, I want to punch that toy there. It looks like some small panda thing. And he says, like, we use that to keep the door open during summer, if you remember the dialogue there. So he goes and punches the toy. It falls down and comes back and hits him again. In case you don't remember that scene, it is there in the first part of the movie. The center of mass is slightly below. So if you make a toy like this, and if you disturb this, so normally when they design ships and all, this is what we also try to do. We try to make the ships heavier at the bottom. That's the reason we keep the engine room, cargo, everything at the bottom. So center of mass is here. So mg will be somewhere here. The normal reaction will be here. Remember, n should always pass through center. So that means this body is trying to rotate this way. So you push it to the right, it will try to rotate to the left. This is a stable equilibrium. That's why I said this is a pretty good question. Even though people think it's a center of mass question, it actually becomes an equilibrium question in work power energy. And the interesting thing happens when h is equal to root 3r. The center of mass is exactly at the center. If you disturb this, mg is like this, n is also exactly like this. They're passing through the same point. There's no rotation, it just stays there. What kind of equilibrium is this? Neutral equilibrium. Neither comes back nor goes away. Do you remember the 3 cases of equilibrium we did in work power energy? So we can bring the cases like this also in center of mass. This would be a good question, in case of matrix matching or more than one choice questions. They'll ask you that only. What's the condition for it to be in a stable equilibrium? They won't ask you center of mass. Have a look at this. Clear, everyone? Let's do one more easy one like this. So basically, I can give you some standard shapes and we can find the center of mass from there. Get me the center of mass of this one. We have a disk. And we have a square plate. This is your origin. This was 2r. This is also 2r. Meaning radius is r and the side of the square is r. Same material. Find center of mass. What is the question for medical students? Where is the center of mass? At the origin, right side of the origin, left side of the origin. That's the medical question. What is the answer?
Right side of the.
Right side. Whoever has more mass will have more center of mass. So yeah. Get this easy one. This is. I'll give you a minute. You took a disk and a square plate and you're touching them. Find the center of mass of the system. So these questions are easy now. You should know the standard results and then just stick them up and you can find the center of mass. Get this. You got a minute. I'll send you a small sheet on center of mass. So different shapes and all, you can do that. Maybe not much, 10, 15 questions. Were you all placed on Sunday evening, right? Any chance all are free around 7 to 9? I just want one extra class because on December 29th I'm not there and I don't want to miss the class. Christmas holiday hai kya? I don't think they'll give. I don't think they'll give. 3 full days, sir. When? Christmas, Rehan?
Sir, Sunday को.
Sunday ko.
Yeah, sir, Sunday.
Chale. We will plan something maybe next week or something. I'll just take up one class. So that 29th, right? The New Year, I'm not there. All my IT friends are coming. I have to go and meet them. And they'll kick me right and left if I miss. Let's see. How to do this thing? I'll ask you anyway. The week which I'm taking, I'll ask you guys and we can plan it out. So for this guy, the center of mass will be where? R comma 0. Let the mass be M1. What is the mass? Sigma into area. 2R whole square. For this guy, the center of mass will be minus R comma 0. Mass, let it be M2. Sigma pi R square. You're done. The only x coordinate will matter. The x center of mass will be sigma 4R square into R minus sigma pi R square into R by sigma 4R square plus pi R square. Sigma sigma goes off. You end up with 4 minus pi by 4 plus pi. Answer is good. It looks neat. Into R. Check. Easy. So just get the mass, just get the center of mass and finish off with the regular formula. M1 x1 plus m2 x2 by m1 plus m2. Palaksh, check your signs. Somewhere it messed up, I guess. Okay. Take a break. Come back by 7-2. Any doubt so far? Anything you didn't understand? Anything you want to ask? You can ask me. Others, you can take a break. Any doubts on anything that we did so far? Vartika, you came at the right time. We just started the break. Sure, I'll be back by 7 o'clock. Yeah. Switch on your camera, everyone. Let's start. There. So this is one kind of thing. The next one is cavities. Quite an important model. This you will encounter at multiple places. So let's say we have a disk here. The cavity. This is a standard question. So this cavity, right, passes through the center and also touches this thing. So basically, this thing has a radius of r/2. We'll do one thing. We'll change the shape. We'll take solid sphere with a cavity. So technically speaking, right, you can't see the cavity, isn't it? Because it's a solid sphere. Inside you can't see. Ever happened? You buy a chocolate or something and you start eating and you find there's a hole inside. The filling. Oh, it happened with my nephew actually. He brought that Kinder Joy, right? And then after opening it, he found out there is a half the chocolate is missing. There's a hole inside. This guy started jumping that he got cheated. So, but welcome to life. So find the center of mass. So you have a solid sphere with a cavity. Remember, solid sphere is a 3D shape. And you removed r/2 cavity touching the center and the circumference. You can do the same thing with a disk also. So this cavity problems, right? There is a way to do this thing, and the idea is quite important. We're going to use the same idea in multiple chapters. So I'm more interested in that idea of doing cavity problems rather than this. Think for a minute. I'll show you one, and then I'll give you something better. So what is the idea for this cavity problem? See,
You add that cavity, then you'll get a full solid sphere.
yep. So the idea here is, whenever you have cavity, you take this and you take this, add it up. Whatever is the cavity, you finish it off. What you will get is a full solid sphere. So for the full solid sphere, I know the center of mass. So the main idea is that whenever you give me something weird, I will just fill up the cavity to make it into a symmetrical shape. So this center of mass, let it be at x comma 0. This center of mass will be r/2 comma 0. Remember that this is point. So for this guy, the mass will be density into volume 4/3 pi r cube. And let this mass be m2, which is rho into 4/3 pi r/2 whole cube, which is 1/8 of the volume, that is m/8. That means automatically m1 will be m minus m2, that would be 7m/8. Is that making sense? If the full sphere is capital M and the small one is m/8, and this is there. So the center of mass of this full system, x center of mass, will be m1 x plus m2 r/2 by total mass m1 plus m2 should be equal to 0. So 7m/8 x plus m/8 r/2 is 0. X is equal to minus r/14. Check. Clear? So the main idea with the cavity problems is whenever you have a cavity, just fill it up and you'll get a regular shape, and from there you can solve. Same thing you can do for a disk also. The idea is the same. Clear with the idea? Yeah, you can take negative mass also, but that concept is only a little weird, negative mass thing. But fine, it works. Basically, what you're doing is the same thing. You're just shifting it this side, and you're saying I'm subtracting it. Next one. We got a square plate. So from this square plate, someone removed a small square like this. This is a square plate of side L. And from this, you removed a small square of side A. This corner is point A. The question is, find A by L. So how much should you remove if the center of mass of this system is at point A? You're getting how is the question? So from this big square plate, you removed a small square plate from the corner. Yeah, have a look at this. There. So a small square is removed from this big square. Is removed from the corner as shown. Let's get this. So that point A, right, which is that cavity corner, that should be the center of mass. Now, this does not happen for any cavity. That A by L has to be a specific ratio. So find that ratio. If A by L, that point is the center of mass. How can A be the center of mass before cutting, right? For a full square plate, what is the center of mass? Then center, right? How can A be the center of mass of a full square plate? After cutting, A is the center of mass, right? Question is clear, na everyone? Someone is confused, please ask. Others, do keep your cams on. The idea is the same. You have to put back that small square piece and you get a full square plate whose center of mass will be the center. A by L is root 2. That's not the answer. So the first thing, if you can take a proper x and y axis, your life becomes a little easy. Can you see there's a line of symmetry here? So I'll choose this as x-axis and this as y-axis. Because I know the centromas will lie somewhere on the x-axis here. So that will make your life easy. So let this point be 0, 0. So you're adding this plus this. You get this. So this mass will be sigma into L square. This mass M2 will be sigma into A square. This mass M1 will be total mass minus M2 sigma L square minus A square. There I got the masses. And you're telling me for this plate which you have cut it, the center of mass is A only. So what will be this distance here? This full distance is L by root 2. And this distance is A root 2. That means this guy ka coordinate should be L by root 2 minus A root 2 comma 0. That will be the coordinates of A. So A ka coordinates are L by root 2 minus A root 2. This will be the center. We are talking about this point here. That would be L minus A by root 2 comma 0. And this centromos will be 0 comma 0. Check your coordinates. Because this would be L by root 2, this will be A by root 2. So if you subtract, you'll get this thing, L minus A by root 2. More of a geometry there. So this coordinates will be L minus A by root 2 comma 0. Aryan, you have to solve and you tell me. Don't ask me for answers. You are given time to solve, not to ask me what is the answer. I'm solving, right? As if where am I running away? Solve. Use the time to think and solve. Na? Who cares about the answer? Now what? Then you're done. So basically, M1 L by root 2 minus A root 2 plus M2 into L minus A by root 2 by total mass M1 plus M2. This should be 0. Just have to substitute the value and finish it off. Finish it off, I'll give you a minute. This would give you the x center of mass of full plate. So M1 will be sigma L square minus A square L by root 2 minus A root 2. M2 will be sigma A square L minus A by root 2 is equal to 0. Sigma goes off, cross multiply. What do I get here? This can be written as L minus A into L plus A, L minus 2A by root 2 plus A square into L minus A by 2. L minus A also goes off. This will become L plus A, L minus 2A root 2 also goes off. This becomes A square is equal to 0. Expand this L square minus 2A square minus A L plus A square is 0. L square minus AL minus A square is 0, quadratic. L is equal to A plus or minus B square, A square, 4A square by 2. This should be plus root 5A. Don't take minus Y because L can't be smaller than A. So you get L by A ka ratio is root 5 plus 1 by 2. That's your answer. Check your steps. Once you got here, it's just a matter of substitution. There's nothing there. You don't take the minus sign because it can be negative. Any doubts on this page? Please have a look at this. I'll show you the next page. There, cavity problems will be like this. It's more of a geometry thing. Easy to solve, but the headache is understanding how to take and everything. Any doubts on this page? Please ask me. Clear? Similar question. You can try this as a homework if you want. Same square plate, but this time I remove the square like triangle like this. You can try that as a homework. This height is h. Side is L. Side is L. This tip A is the center of mass. If A is center of mass, find L by h. Idea is the same. So that you can try as a homework. So I can cut off any kind of shapes and it works the same way. So here I removed a square from a square. Here I am removing a triangle from a square. Clear? Got this? Can I turn the page? So that is one variety of problems there. About calculation of center of mass, cavity ones. Cavity ones are pretty good. Next one. Motion of center of mass. We know the center of mass ka position vector is sigma mi ri by sigma mi. Now, if you differentiate with time, this will give you velocity of center of mass. This will become sigma mi bi by sigma mi. So sigma mi is nothing but the total mass. If you bring it to the left hand side, this will become mvcom is sigma mi bi. That's nothing but m1 v1 bar, m2 v2 bar, so on till mn vn bar. So this is momentum of the system. So basically, if there are n particles, you're adding all the momentum of the system. This is the momentum of the system. On the left hand side, this mvcom is nothing but momentum of the center of mass. Quite a useful statement. So if you give me some random shape with thousands of particles and you ask me momentum of the system, you need not find for each particle. Just find the center of mass and then find the momentum of the center of mass. So assume all the masses at center of mass and finish it off. That will be the momentum of the system. Now, if you differentiate this quantity again, VCOM, acceleration of center of mass will be dVCOM by dt. That would be sigma mi dvi by dt by sigma mi. So acceleration of center of mass will be sigma mi AI by sigma mi. This also you can arrange this. So this will be total mass into acceleration of center of mass would be m1 a1 plus m2 a2 so on till mn an. That is nothing but force on the first particle, force on the second particle, force on the nth particle. If you add all the forces, we get total external forces. Internal forces cancel out. So till now, what you're doing, work per energy was when you're writing F is equal to ma, that A actually belongs to the center of mass. So how did we actually derive this formula, center of mass? We didn't dream about this, okay? It was actually derived from Newton's second law. You took F is equal to ma, then you expanded this as F1, F2, Fn, m1, a1, m2, a2, nn. From there you got this, then you integrated this, then we got velocity of center of mass, then you again integrated this, you got center of mass. So the center of mass, the position of center of mass is actually derived by integrating Newton's second law 2 times. This is the proof how we got the center of mass actually. These are the important things to remember for center of mass and acceleration of center of mass. So whenever you're saying F net is equal to ma, that acceleration is not for a single particle. It is actually the acceleration of the center of mass. So a body can have different accelerations, but I'm interested only in the center of mass. We never actually bothered about this thing. So F external is this thing. Now if F external is 0, this implies acceleration of center of mass is 0. This implies velocity of center of mass is constant. Therefore, momentum is constant. This is your second powerful weapon, law of conservation of linear momentum. So this is your second conservation. In entire mechanics, we have 3 conservations: law of conservation of energy, law of conservation of linear momentum, and law of conservation of angular momentum. Law of conservation of linear momentum. Next class, I'll give you a small algo, like, when you see a problem, how do you know whether you have to use conservations or forces or whatever? Please have a look at this page. That is this initial momentum. That is fine. Initial is equal to final. Clear with this? Any doubts on this page? That's only that if you see that all we did was actually double differentiation. So think of like this, it was the other way around also. From here, I proved Newton's second law. Means what? Since Newton's second law is always valid, that means center of mass should always exist for a system. So center of mass is not some hypothetical imaginative point that we thought of. It actually does exist for any kind of system. So here, few points about this. If F external in a direction is 0, if F external in a particular direction is 0, then linear momentum in that direction is constant. So total force should not be 0. Let's say force is 0 only in the horizontal direction, then only horizontal momentum is conserved. Second, internal forces do not affect the center of mass. Only the external forces can affect. That is, it will continue with whatever velocity it is going before. Let's say if you throw a bomb into there and it explodes, explosion is an internal force. So the center of mass of the bomb after explosion will continue to follow the same path as if there is no explosion. Momentum of the system with respect to center of mass is always zero. Think about it. If you go and stand on center of mass, what will you think? Center of mass is not moving. If center of mass is not moving, then the momentum is zero. And momentum of the system is momentum of center of mass. That is, therefore, momentum is always conserved in center of mass frame. This would be a good, more than one choice statement question. Momentum is always conserved in center of mass frame, even if forces are acting. True, actually. Momentum is, because it's always zero. Momentum is always conserved. So if an observer is standing on the center of mass frame, momentum is always conserved, even if external forces are acting. Generally, if external forces are there, momentum is not supposed to be conserved. The center of mass can be treated like an independent particle. If someone asks you find the position of center of mass, you need not find all the particles and find center of mass. Find the velocity, find the acceleration, and just treat it like a new particle. That is, acceleration of center of mass is dv/com by dt, or v dv by dr. Again, just add everywhere center of mass, center of mass, center of mass. V center of mass is dr/com by dt. And if acceleration of center of mass is constant, we can use the three kinematics equations. B is equal to u plus at. The only difference now everywhere, center of mass, center of mass, center of mass. S is equal to ut plus half at square. Again, center of mass, center of mass, center of mass. V square minus u square is 2as. You can use all your regular kinematics, everything. In the first point, will it be always horizontal? No, sorry. It should be conserved in that particular direction. I think while giving an example, Flomey wrote the same thing. Whatever direction the force is zero, in that direction, momentum is conserved. Have a look at these points. So those are some of the theoretical points. Among all this thing now, the second one is a standard one. The third one is a pretty good one. Even at an advanced level, it's a good one. Did you understand this statement here? Malika, that part is clear. So if it is always zero, that means even if force is there, it is not there, it is still zero, right? So if it is initially, if it is zero, finally it is zero, then isn't it always constant? Isn't that what we call as conservation? So because the center of mass is like, if you stand on the center of mass, you think it is at rest. And if it is at rest, meaning momentum is always zero. वो logic था. Okay? Let's see some questions on this. So we have a particle here projected with 20 √2 meters per second. 45 degrees. We have a particle here 25 meters per second. 37 degrees. Let this particle be B. Let this particle be A. Let this mass be 2m and let this mass be m. Find velocity of center of mass, acceleration of center of mass, h max of center of mass. So there are two particles, m and 2m, projected with 22 and 25 as shown. Find the velocity of center of mass of these two particles, acceleration and maximum height of these two center of mass. Try. Get the h max. Give me that answer. Remaining is fine. I have an idea. Tell me whether this thing is making sense or not. I will find this h max. I will find this h max, and I'll find the h max of these two. Will that work? Why? Such a brilliant idea. What is the problem? What's wrong with that? Masses are different. So, projectile motion, when did masses started affecting you? Look at my idea there. Okay, we have one answer. I'm saying I will find the h max of this particle, I'll find the h max of this particle, and I find the h max of these two. Center of mass can't go more than that. So that should be the h max of the center of mass of these two particles. So what do you think? Why is this wrong? It is not always about knowing how to get right answers. You should know what kind of goof ups you can do. School mein wahi problem hai. School mein you're so focused on getting the right things done, people don't understand how to, stay away from wrong things. Anyone? Adrit said it right. Anyone else? What is the guarantee both will be at the maximum height at the same time? When this thing has reached h max, maybe this is still going up, na? If both reach the h max at the same time, then it is true. They both don't reach their respective maximum heights at the same time. Is that making sense? That's where that thing becomes wrong. Idea was decent, but that's a blunder. There's no guarantee both will reach their respective maximum heights at the same time. How to do this? Previous page, this one. Done? Get this. Try, give me a minute more. That's why I keep saying, it is better to solve, like, let's say 100 questions, and after solving them, resolving them and understanding what kind of mistakes you could have done, how could you have solved the question much faster? Is there any way you can guess this thing? That would have been a better way than rather doing 400 questions. I would prefer you're doing 100 or 120, but doing them thoroughly and trying to figure out in different ways than doing 300-400 questions, just for the sake of doing a lot more. That is the reason, right? Most people mains handle kar lete hai, but advanced when it comes, right, they start stumbling. Because you don't think about, what can go wrong, what else is the possibilities. Because mains mein, you just get the answer, you're happy. And that is the kind of thinking that is required when you go to IITs. In Israel, when they formed the state initially, they were looking for an attack. I think some country was about to attack them, and everyone said, no, they don't attack. They said, like, it is highly impossible that the so and so country can attack Israel. Karke. But there is one commander who said, yeah, nay, there is a possibility. And people ignored him. And attack happened and many people died. Not the recent one, long back. And then after that, right, Israel made sure in a committee of 10 people, there'll be a 10th guy who will always take the opposite of these 9 people. His job is to come up with a plan, such a weird thing, impossible things. Like, this guy should always come up with an idea like saying, yeah, this, if these people say yes, this can happen, this guy will say, no, it can't happen. His job is always to negate and give a counter argument why it can't. And that thing actually helped Israel a lot. This time something weird, but that is how, that country, such a small country, could survive in middle of so many, these Arab countries. Everyone hates it, but still it survived in the middle of them. Because there's always one guy who says, that is possible. This is impossible. It's important, how things can go wrong. The tomorrow of your own company, more than making sure things are getting right, you have to just make sure things are not going wrong. So velocity of A will be 20 root 2, 20 I cap, 20 J cap. Velocity of B will be 25 cos 37. Cos 37 is how much? 4 by 5. Minus 20 I cap and 15 J cap. So velocity of center of mass would be M into 20I, 20J, 2M into minus 20I, 15J by total mass is 3M. This would be minus 20 by 3 I cap, 50 by 3 J cap. Acceleration center of mass, both of them are having minus G only. So M into minus G J cap, 2M into minus G J cap by 3M is minus G J cap. Now here H max depends only on this is your Vx component, this is your Vy component. This is how you find H max. H max depends only on the Vy square. So Vy square by 2Ay. 50 by 3 whole square by 2G. That's your answer. That's what I was saying. You can treat the center of mass like an independent particle. To find the velocity of center of mass, find acceleration of center of mass, and just finish off just like a new projectile. Finding for A separately, B separately, and trying to find, you have to use differentiation, cal maxima minima. That would be quite complex. You just treat the center of mass like a new particle, find its maximum height, and you're done. This would be 2500 by 18G. Yeah, 250 by 18. Do check your answers. Clear? Any doubts on this? Turn in the page.
So can you go back for a minute? Yes, sir. Thank you.
We have a pulley here, we have a block here, M and 2M. This is an easy one. Find the acceleration of center of mass. Here find magnitude of acceleration of center of mass. Here find acceleration of center of mass. Get them. There, you can bring your NLM also into center of mass. Get the A part. A part is easy. Hope you remember Atwood machine. Do make sure your cam is working next time. Huh? Sort it out. Okay, first one is easy. Hope you remember this thing. This would go down with A. This is with A. This is 2mg. We use net pulling force method, or you can directly use the formula there. Check it out in laws of motion in case you don't remember. So this is the acceleration. G by 3. This much you should know. So acceleration center of mass will be here. Be careful. This is m by 3 j cap. The sign is important. 2m. This is minus g by 3 j cap. If you take it as plus, you will go up. The total mass is 3m. So the answer will be minus g by 9 j cap. That is a mistake you do. What about the B part? G2 root 3 minus 1 by 6. Let's see. I'm not sure whether that is the answer. Do check out the 16th one. 16A is easy. G by root 3 minus G by 6. Now, the reason why I asked you only magnitude, that you need to understand. Because trying to find the acceleration center of mass I cap, J cap is a big mess. So luckily in this diagram, there is something nice actually, which makes your life easy. I can treat this as x-axis, I can treat this as y-axis. Because this is 90 degrees. If that had been any other angle, it would have been a big goof up. You could have calculated it, but it would be quite lengthy. So this acceleration would be A. This is 2mg sine 60. This acceleration would be this way. This is mg sine 30. So using the net force method, that is the forces along the string. So acceleration will be, so if you see 2mg sine 60 is in the direction of acceleration. Mg sine 30 is opposite to acceleration. In case you forgot the net pulling force method, definitely go back and revise NLM notes today. It's forgetting is totally fine, but then you should know that you should go back and do something about it. And if I solve this, I end up with m gets cancelled. 2 sine 60 is root 3 minus half g by 3. Fine, I got a k value here. Now, since I asked me for the magnitude, acceleration center of mass, I can take that as 2m a I cap plus m minus a j cap by 3m. If I don't ask you magnitude, then problem kya hoga? I have to divide this A into I cap, J cap, this A into I cap, J cap, and then we have to do. You can do that, but since I just want the magnitude here, M gets cancelled, 1/3 root over, A comes out here. Root over 2 square plus 1 square. Root 5 by 3A. And A ka value is that, substitute. Check it out. Clear? What is A center of mass? M1 A1 bar plus M2 A2 bar plus M1 plus M2. So this is going in which direction? This is going in I cap, no? This is going in which direction? Minus J cap, right? Opposite to Y axis. Right? That's it. So M1 A1 bar plus M2 A2 bar. Sure, you have to take it in vector form, isn't it? You directly can't add them. All got this? Any doubts on this? Udayan? Arjun? Clear? Palaksh? Neil? Vidyut? Clear with this? Abhinav?
Yes, sir.
Last one for the day. We have a circular track here. And we have a toy train. Which is going with speed u. Semicircular toy train of mass m. It's going with constant speed. So it is going in a meaning circle with a constant speed. Find velocity of center of mass. Remember, every point on the train will have speed in different directions. You can't directly add the speeds. So on a circular track, we have a semicircular toy train of mass m is going in a circle. Find the velocity of center of mass. What is a catch? One way is to do integration. That's too long actually. There's a faster way. Pi u by 2, nah. Let me ask you some questions. Where is the center of mass for semicircle?
Okay.
2r by pi. So when the train goes from here to here, what will the center of mass do? Let's say when the train becomes like this, what will happen to the center of mass?
It will go
Center
like
mass also will go like this, na?
QR by 5.
Yeah. So basically, if the train is going in a circle of radius r, the center of mass goes in a circle of 2r by pi. So what is same for the train and the center of mass? What is same for the train and the circle mass? Yep. Center of mass moves in a circle. Omega is same. With same omega as the train. That means velocity of center of mass will be 2r by pi into omega. But what is r omega? V. U, whatever is that. U is equal to r omega for the train. That's it. So if you got that idea, you get the answer in what, like 10-15 seconds. The main idea is that if the train is in a semicircle, center of mass is 2r by pi. So whenever the train moves, center of mass also is going in a circle. So both will have same angular velocity. The radius of the circle is 2r by pi. So the speed is 2r by pi omega. Easy? Please check. This should be a good mains level question actually. Not tough, right? But if the idea strikes, it is easy. But if you try to do with integration, you can do it. You take a small piece here, d theta. Then we say momentum is I cap, j cap. Then you integrate all I cap components, j cap components, and then it was quite long. Indirectly, you're finding the center of mass only. Okay, so with that is the last one for the day. So next class when we catch up, we're going to do potential energy of center of mass, kinetic energy of center of mass, and then we will see some center of mass ka, motion ka problems based on that. And then we will start off with, we'll slowly entering into conservation of linear momentum problems after this. Okay, so with that we'll wrap up for the day. So next class we'll catch up on Wednesday as usual. The test is there till night 11 today. In case you didn't give, so do make sure to give it. And I'll post the paper and the results by Saturday or Sunday morning. Right? And then if there are any queries, we can discuss. But the paper is quite easy actually, if you see. It's not really tough. It's a good paper, so do give it. Okay, so with that, we wrap up for the day. So, and we have done almost like 17 questions, especially all those integration problems, right? Try to do them on your own. It's important. Like I said, integration is not tough. How to choose elements and is an important thing. So try to do them without seeing once. And I'll send you a small center masker sheet also. Okay.